Statistical Rethinking, second edition, and we're on Chapter 11, and this is the last of the easy questions, question 11E4. And so the question is, why do Poisson regressions sometimes require the use of an offset? Provide an example. Okay. So here's how I'm going to answer this. Okay. So say that we have an outcome variable that is something like a rate, okay, a fraction, right, where we have the number of events in the numerator, and then in the denominator is something like the number of attempts or space. So it might be like how many plants of a certain species are within a certain area, or the number of events in a certain time, or generally exposure, okay. And furthermore, that the different observations have different denominators, different m, right? A different number of attempts, a different area, etc. Okay. Well, then we might have a model that looks something like this, where g is supposed to be our link function, okay, and our outcome is this fraction, and so it might look like this. Some function of the fraction equals this linear model here. Okay, but we don't have a GLM in our toolkit that accounts for fractions. Okay, and so this is a problem if we want to somehow model this fraction. Okay, so the way that we get out of this conundrum is, so let the link function be the log, or I'm using natural log. Okay, so instead of g, it's the natural log. Well, now we have the natural log of this, right? So again, the natural log is the link function of this thing. Well, we can rewrite the natural log of a fraction as the natural log of the numerator divided by, or I'm sorry, not divided by anymore, minus the natural log of the denominator. Okay, so now we have that this difference equals our linear model. And then we can just take the natural log of the denominator, or of m, again, where m is something like the exposure, okay? We can just take that over to the other side, right? And so now we have that the natural log of y is our original model plus our natural log of m. And here the natural log of m is our offset, okay? And so what we have here, insofar as at least y is a discrete random variable that's always positive, what we have here then is a Poisson regression with an offset. Okay, and so, well, I guess that answers the question.